Welcome back. This lesson is the third in a series about the prime exposure factors. Here we're going to be talking about the kVp. kVp is actually an acronym that stands for kilovoltage peak. The kVp is what accelerates electrons and forces them through the X-ray tube. So basically, here's what's happening. During an X-ray exposure, the cathode is negatively charged and the anode is positively charged. This difference in charge is called the tube potential. We measure the tube potential in units of kilovolts. When we increase the kVp, this creates a larger voltage difference across the X-ray tube. This causes the electrons to move quickly, which then gives them more energy and produces a higher energy X-ray beam. When we decrease the kVp, this creates a smaller voltage difference across the tube, and therefore the electrons move more slowly through the X-ray tube. They have less energy, and the X-ray beam has less energy. So why does any of this matter? Changes in kVp have very important effects on the X-ray beam. If we increase the kVp, this will increase the beam intensity, just like increasing mass. But something else also happens. Increasing the kVp increases the energy of the X-ray beam. In other words, kVp affects both the quantity or intensity of the X-ray beam as well as the energy, which we also call the quality of the X-ray beam. kVp is unique for this reason. It is the only prime exposure variable that can change the energy of the X-ray beam. No other variable can do this. The mA cannot change the energy of the X-ray beam. The exposure time does not change the energy of the X-ray beam, and the distance, or SID, does not change the energy of the X-ray beam. Only the kVp controls the maximum energy of the X-ray beam. The mathematical relationship between kVp and the X-ray beam energy is actually very simple. The kVp is mathematically equal to the maximum beam energy. So in this example, if the kVp is set to 100, the maximum energy photons in the beam are going to be 100 keV. So not all photons in the beam will have 100 keV, but some will. keV is actually an acronym that stands for kilo electron volts, and that's just the unit of measure for quantifying the energy of X-ray photons. The mathematical relationship between kVp and the beam intensity or quantity is slightly more complex. It looks like this, but the main thing you need to understand is that changing the kVp definitely does have a large effect on the beam intensity or quantity. We also need to understand that kVp affects other aspects of the exposure as well. Increasing the kVp increases the dose to the patient. This is because increasing kVp creates more X-ray photons, which means more photons are striking the patient. Obviously, the reverse is also going to be true. If we decrease the kVp, this decreases the patient dose. kVp also affects the receptor exposure in a similar way. If we increase the kVp, this increases the receptor exposure. This is an effect of the increased beam intensity and because the increased energy results in more penetration through the patient. As with all of these relationships, the opposite also should be understood as true. Decreasing the kVp decreases the exposure to the receptor. This is because fewer photons are created and fewer photons will penetrate through the patient. The relationship between kVp and receptor exposure is actually defined by the 15% rule. As an example, if we increase kVp by 15%, this will double the receptor exposure. Finally, kVp also has an important influence on image contrast. The reasons for this are discussed in other lessons, but the relationship we need to know is that increasing kVp actually decreases the image contrast. And of course, the reverse is also true. If we decrease the kVp, this is actually going to increase the image contrast. So in summary, here's the major relationships we need to understand. If we increase the kVp, this is going to increase the energy of the X-ray beam, and it also increases the intensity of the X-ray beam. We also should know that when we increase kVp, this increases the patient dose and it increases the receptor exposure, but increasing kVp decreases the image contrast. Here's a practice problem to make sure you understand these concepts. Changes to which of these technical factors will influence the receptor exposure? Choose multiple correct answers. Take a minute to decide what you think the answers are. In this question, all of the variables will affect receptor exposure. Tube current, which is the mA, exposure time, which we measure in seconds, tube potential, which is just another name for the kVp, and the distance, or the SID. These all influence the receptor exposure, which is why we call them the prime exposure factors. Here's another question. Which of these variables influence the energy of the X-ray beam? Take a moment to figure out what you think the answer is. In this question, there's definitely only one correct answer, and that's the tube potential, also known as the kVp. Unlike any of the other prime exposure factors, only kVp affects the beam intensity as well as the energy of the X-ray beam.